My name is Jyrki Huusko, and I will continue on the topics what also Sasu mentioned about this networking issues. So having a little bit deeper look on what we have been doing for networking the resource-restricted small devices in our Internet of Things project. So basically, this is just an outline of the presentation I will have. So telling a little bit about the main goals, what we have for the networking and communication side, about the radio technologies, what we have studied a little bit, and networking, and also the communication security as one of the main topics on this side. So this is basically a little bit lower layer topics than the others in a project. I have a couple of slides also for the demonstration examples what we have accomplished during this 1.5 years now in the project. So I guess that's the main themes now in my presentation. So going to the introduction on networking and communications. So basically, what we are dealing here is the different kind of radio technologies. So trying to enhance the already existing ones, and then also there is a plan to look a little bit deeper on what sort of new solutions we could probably introduce. For example, in terms of cognitive radios and that kind of thing. So that's something which is one of these things. We haven't taken a look of those yet, but probably in some point of the time in future. And then on the second point, there's this networking of small devices, concentrating mainly on the networking protocols, gateway architectures, and connecting on the upper layers the different devices. And then as a third point, the communication security. So in that section we have been looking, for example, different kind of bootstrapping systems, authentication and security solutions for the communication. So as a main goals, the one big thing is of course the enhancement to the different radio technologies and wireless standards to make those as suitable as possible for the IoT solutions. Thinking that most of the solutions they are quite power hungry, they are quite complex. So if we want to introduce those on small devices and really resource restricted devices, we need to do some modifications, some enhancements for those. For example, cellular systems are good in that way that we can guarantee a larger coverage areas, but there is also in the problems, for example, the energy consumption side and so on. The second thing, or the second goals are actually to deal with network layer algorithms, protocols, and also there is the main themes are for the energy efficiency and performance on the IoT infrastructure and environment. Scalability is one of these main themes or main questions, research questions, how we can provide a scalable environment, what kind of protocols we should use in order to be scalable and at the same time also energy efficient. And evolution of gateway nodes. So we have trying to find good solutions, how to actually define, how to build good gateways for the Internet of Things purposes. What sort of features there should be in a gateway in order to be operational and in different kind of environments. And of course, as I mentioned already, or the security of the whole communication infrastructure, not only for content, but also for the actual content or the communication infrastructure. So if we go a little bit deeper on these three different themes, radio technology, networking, and security, one thing what we have been doing is evaluation and comparison of different kind of radio technologies, and so that if they are really suitable for machine-to-machine communications. So there are basically several different requirements what needs to be taken into consideration, and one of course is the network and channel access. So how to really efficiently handle the network access for the devices. So basically medium access control solutions in order to be energy efficient and able to also provide a connectivity in varying situations. Second thing is handling the small data. So there is a lot of problems coming from the signaling overhead, for example. So how the different kind of radio technologies could handle that kind of small data situations where basically the uplink, as Sasu said already, that uplink is there quite occupied in that way. So a lot of traffic is going uplink from the small devices. How to really handle that kind of situations. And also the signaling for the management of the system, how much that kind of traffic is needed for upholding the actual connections, and that's causing quite often a lot of overhead in communication, and minimizing that would be one of the key issues. And third one is the power consumption requirements. So we'll take a look of what kind of requirements first of all we will have, and how to then improve the energy efficiency on the radio access level to minimize the actual power consumption. So these are one of these main things what we have looking for the evaluation and comparison of different kind of radio technologies for the IoT. The second main thing is actually what we have been doing there is enhancing the current standardized solutions for machine-to-machine communication, and one of the promising technologies is actually the 3GPP long-term evolution. So basically thinking about that, what is the motivation of going for this LTE side. Of course, we can think that there is a lot of other solutions too, but LTE actually is good in that way that it provides an easy connectivity and deployment of IoT devices. As the 3G, it has a quite high deployment characteristic already. So you can see on the world map on the lower end of the slide, there is the red ones are the areas which already in 2012 have included the deployment of LTE technologies, and blues are actually in 2012 were upcoming, and there is plans at least in really short term to launch commercial activities on that. So covering a lot of areas, being as a global standard for communications. That's one of the things which could motivate you to actually think about LTE also as a machine-to-machine communication radio technology. Giving a large coverage area compared to the short-range ones, and also there is already existing, for example, security frameworks which could be potentially used for machine-to-machine too. Even though there's a lot of good things which supports of applying the LTE as one of the main technologies, there is a lot of challenges on that. So it hasn't been designed well on IoT world. So signaling overheads with large number of devices, that's something which is restricting the use, and also the energy consumption and battery lifetime for the really small devices. That's hindering the development that side. But that's something what we have been now looking for in IoT project, that how we actually could go over on these restrictions. On the networking side, the improving the internet connectivity is the main theme what we have been thinking about or looking for, and thinking that of course almost all the user services and communications are IP based, then we really need to have also something in sensor side which can be interact with those services and so on. Web compatibility starts to be quite a mandatory feature, so everybody wants basically use the things and services through the web browsers and using, for example, HTTP as today is the main way to do it. There's a lot of technologies trying to solve the connectivity issues on the protocol level. So there is IETF, OSIS, ETSI, trying to find a good solution standard, and there we come with the interoperability issues. So how to actually make these systems globally connected. So how to provide systems which can support the different kind of standards. That's one of the things. So interoperability connectivity issues are the challenges still which we are trying to tackle on, and then how to make a communication infrastructure scalable enough and also the energy efficient. What we started to do in the beginning of the project, we wanted to, since gateways have a specific role in the IoT system, and they are sort of bridges on the system, connecting the actual sensors and devices and the content of that to the services, and also provide the possibilities for the interoperability of different kind of systems. So what we started to do is to trying to find that kind of modular way to build the features or collect the features for gateway devices. So what are those mandatory features, and can we actually enhance the gateway solution by adding dynamically some new features if they are necessary. So trying to come up with a generic platform which could be then usable for gateway. On the communication security, we just moved to the third part of the topics what we are dealing with. What we have been doing with the recent years is taking a look of how to provide an authentication methods to the small devices, and how to actually be flexible also in that way. So one of the main themes what we have been dealing with this generic bootstrapping architecture and how to apply that on small devices. Basically, that's something which is standardized on 3GPP, so it also fits on the scope on the radio technology side too. So it's a SIM-based authentication. Of course, the problem is that it's not a trivial to identify and also bootstrap, and also that needs the SIM authentication for the devices. But of course, cellular operators already have infrastructures, and hopefully that would be the way how to enable also the secure bootstrapping on the small devices. And what we have been doing here there is also to look for the different kind of solutions, and GPA is not the only one, so there have been evaluation of other possibilities too, like OpenID, HTTP digest certificates, and other things that how to actually manage with the authentication problems. And finally, thinking what is our main goal is to how we could actually put also these gateways to the cloud. So how these resources could be located in that kind of place where you are able to access easily those, and also handle the data efficiently. So take a look of the figure here. You could, for example, have a different kind of application areas. You could have an industry using their own sensor environment. You could have a public services. There is a different kind of sectors: police, fire department, public transportation. Every of these parts needs some sort of resource services for the. So they have a lot of sensors. Also, the resources of the sensors, they need to somehow know that what kind of sensors there are, what are the content of the sensors, and so on. Also, the home could be one of these specific cases, and each of these basically could provide the data to cloud, and then how to actually build that so that the resources could be stored there. Everybody has a secure access to their own data there, and so on. Thinking about the different kind of solutions where this work package also concentrates is that each of these probably have some sort of sensor networks, wireless sensor networks, or wired sensor networks with perhaps short-range communications. In that case, probably they would need some sort of gatewaying system to actually interact with more global resource directories. But then there is, of course, possibility that we will have also the long-range communication. So basically, each of the devices could directly be interacting with the cloud systems where they store where the resources are stored, and also probably the proxy services, which then allows the content processing also in there. And most probably the end users have some sort of long-range radio devices, cell phones or so, which they could then interact directly to the cloud. And actually everything needs to, or communication security needs to take care of everything. So authentication, communication, security in general for accessing the data and accessing the resources for the different parts. So it makes the systems quite complex, and there's a lot of work to do actually in order to really get that kind of system operational. All right, so that was sort of short introduction of what we have been doing in generic level for during this 1.5 years basically in IoT Internet of Things program. And now I have a couple of demonstration activities what we have done just only for the communication and connecting the sensor devices to the network. So basically what we have been focusing on is a constrained application protocol COPE, how to utilize the COPE in different kind of situations, different kind of devices and so on. And the main target has been to actually build up that kind of system which is scalable, energy efficient, and also the services, the resources could lie somewhere in the cloud in future. So going first to the closer to the sensors, what they have been, what we have accomplished there. One case is that COPE-based energy metering sensor network. So building a energy metering sensor utilizing the COPE on transport protocol. So we had a multi-hop sensor network, 6-LoWPAN network, and a border router which actually connects then to the actual internet. So all the information coming from the sensors, they are then pushed to the COPE gateway so that you can find, or the people can find the resources and know that which energy meter is which, for example. And then be able to also access the actual energy meter data through this COPE gateway and mirror proxy. Then the next step is that what happens when when you get the actual data before you, for example, store the data inside the repository from the sensors. So for that, and also interacting with the different kind of sensors, sensors which probably doesn't directly utilize or support the transport protocols like COPE, or application protocols like COPE, how to actually interact with the multiple different kind of devices, and then give the support of, for example, for COPE-based communications. So for that, we build up an data collection and processing, basically a library which you can modify to act in different situation. So it's a complex event processing platform where you can quite easily implement a different kind of algorithms to make a decision about the information, or, for example, managing the devices itself. So in the demonstration we have COPE support for this thing. So basically it collects the sensor information, even for example from the analog devices, and then transform that to support the COPE application protocol. And also it handles the header compression methods and access network selections. Then when we look of the gateway itself and also clients partially, so what we did is implementations of resource directory, COPE resource directory, and mirror proxy, and these have been used also as a demonstration, part of demonstrations earlier. So REST model for seamless integration on the web. So in principle, you can then access also the resources and the information from the sensors through the web interfaces using the HTTP methods, for example. And including that mirror proxy and resource directories, the specific COPE protocols for sleeping devices and low power devices have been made. There's a couple of implementations also for different kind of gateways, residential gateways which we accomplished and also integrated in larger demonstrations. So basically utilizing also the COPE and communicating with the resource directory in the system. And when we go a little bit further away in the communication network infrastructure, and we come to the situation that how does the gateway actually communicates to the application servers, or for example in that cloud systems. For there we have the solutions to utilize multipath TCP as a protocol for the multipath communication. So decision that we could, if the, for example, network is congested or there is no link on the network, then we could utilize kind of multipath communications on the system. And finally, one example is that generic bootstrapping architecture, where we already also have one demonstration based on the Arduino Mega platforms and then software implementations of that. So this is currently in Ericsson. We don't have it demonstration here, I think, unfortunately. And actually, if you go to the booths there, you could see one demonstration which actually demonstrates, or the target is to demonstrate the scalability improvements for the system. So basically, how do you make an architecture in that way that you could utilize the local and sort of a global root resource directory. So, for example, thinking that these clouds could be a different kind of areas. For example, even moving like trains or buses, and in there you can actually collect the device, the sensor information, but then how you will be then giving the most appropriate information to the end users. There we have made an architecture in so that basically when it's necessary, these gateways, these local gateways are communicating to this root gateway and then provide that way the information to end user. So I think I've used my time up, so actually that was the last slide basically. So as a summary, we concentrate on radio technologies, networking and communication solutions. Did an evaluation of different kind of solution and look how they fit on IoT, on machine infrastructure. Then in networking, the main focus was on utilizing the CoAP protocol and do reasoning, complex event processing based on how to most efficiently access the network, access the information and handle the network. And on security, the main considerations were on generic bootstrapping architecture, key exchange and authentication solutions. I think that's more or less concludes my presentation today.